In today's video, we're going to make some diethyl malonate, which is a useful building block in organic chemistry. Traditionally, it's made from chloroacetic acid, but that requires handling cyanide. Not only is quite toxic, but also is controlled chemical. So I'm going to make it directly from malonic acid and ethanol. In terms of chemicals, there are only some simple chemicals needed: malonic acid, absolute ethanol, and sulfuric acid as a catalyst. First, 105 grams of malonic acid is charged into a flask. Then, about 500 milliliters of absolute ethanol are added, and the magnetic stirrer is turned on. Wait until all the solid has dissolved, and 15 milliliters of concentrated sulfuric acid is slowly poured into the flask. If the temperature rises above 60 degrees Celsius, let the solution cool down before adding all the sulfuric acid, or the solution might boil. Then the hot plate is turned on and begin to reflux. So what's happening in the reaction flask? This is a simple esterfication reaction. First, acid is protonated, and a lone pair on the alcohol attacks the protonated acid, which forms a tetrahedral carbon center. With the hydrogen shift, this tetrahedral carbon center collapses to form the final ester. Reflux is continued for 4 hours and allowed to cool. Then the whole reaction mixture is poured into water and thoroughly mixed. About 300 milliliters of toluene is added and stirred for 30 minutes. Then the toluene layer is separated and fractional distilled. I found out that fractional distillation is absolutely required. Azeotrope of water and toluene came over first, followed by pure toluene boiled at 110 degrees Celsius. Finally, diethyl malonate was distilled over at 195 degrees Celsius. Fraction between 105 and 200 degrees Celsius is collected. The yield of diethyl malonate is 72%, which is not bad because I did not use any water-absorbing material, such as molecular sieves, to push the equilibrium. This diethyl malonate will be used to make diamidol in the future, and here's a good place to end the video.